Good afternoon, everybody. Welcome to RSK's July edition of Down to Earth. This month it's on PFAS and presented by Chris Hughes, and then Dirk will be joining us later with some Q&A. Just some housekeeping for you. Everybody who's attending the presentation today will be on mute. You'll notice on the right hand side you can ask questions, so please post questions, which we'll then have a Q&A at the end for about 15-20 minutes just to answer any questions you've got. So I'll hand over now to Chris for the presentation.
Thanks, Adrian. So welcome to today's Down to Earth presentation. The presentation's on a topic which is getting a lot of attention at the moment, and that's PFAS. As Adrian mentioned, my name is Chris Hughes, and I'm joined by my colleague Dirk, who will assist me when we get to the Q&A session at the end of the presentation today. We'd like to start just by introducing ourselves. So we'll briefly introduce ourselves and then we'll get into the presentation. So as I mentioned, my name's Chris Hughes. I qualified as a hydrogeologist about 25 years ago. And after spending about 8 years in consultancy, I joined Chevron to manage their downstream soil and groundwater remediation portfolio in the UK and Ireland. And later that included Belgium and Netherlands. And after 17 years, I joined RSK about 1 year ago now, and I'm currently managing their Centre of Excellence team, which is there primarily to support the Shell programme with supporting project teams with complex investigations and remediation projects. But that team is also available to all of the RSK groups to utilise. Dirk, could you introduce yourself?
Yes, I'm Dirk van Look. I am working approximately 27 years in consultancy. Before that, I worked in Africa, development work. But since I'm working in Belgium, I'm doing mainly site investigation and remediation. My main focus is working with clients, guiding the clients through the process of getting a remediation done from start to end. So I started in the beginning with preliminary investigations, and at the end I did some remedial action. I made remedial action plans and guided the client for remediation works. The last 10 years I doing this job within RSK, and the last 5 years we are focusing on PFAS, which is a new challenge in our sector.
Thanks, Dirk. So for the duration of the presentation, we will have our cameras off, but fear not, we will return for the Q&A session at the end. So let's begin. Okay, so when we were approached to provide a PFAS related webinar, the feeling was that we really needed to build awareness of PFAS, not only with project teams, but with clients, so that they could understand what PFAS is and recognise the signs and triggers when PFAS studies may need to be incorporated into site assessment or due diligence scopes of work. So today we will not be getting into complex chemistry. We won't be discussing the challenges associated with PFAS sampling or talking about innovative methods of remediation. With this presentation, we're aiming to build awareness for today's attendees by answering the 3 questions on the screen. What is PFAS? Where will I find it? And should I be concerned about it? And if that leaves you wanting more, then we can share details of RSK Resources you can call upon if you have further PFAS questions. Okay, so what is PFAS? The most widely used definition currently is that developed by the OECD in 2021, who describe PFAS as fluorinated substances that contain at least one fully fluorinated methyl or methylene carbon atom. So PFAS substances need to have at least one CF2 or CF3 bond within their structure. So I've put some examples of some PFAS compounds on the screen. On the left-hand side, we have the most well-known PFAS compounds. They're PFOA and PFOS. These compounds have been researched the most in terms of fate and transport and toxicity. And as you see, both have either 7 or 8 fluorinated carbons. Both for PFOS and PFOA compounds are listed as persistent organic pollutants under the Stockholm Convention, and the use of PFOS has largely been prohibited since 2006, while PFOA was prohibited since July 2020. On the right-hand side, I've got some further examples of PFAS compounds. More information is starting to appear regarding other PFAS compounds, and particularly the fluorotelomers. So here we have an example. It's 6,2-FTS or fluorotelomar sulfonate. They also have 8 carbon elements within their structure. However, only 6 of them are fluorinated and 2 are bonded with hydrogen. The fluorotelomers are getting closer attention as they've often been substituted for PFOA or PFOS when their use has been restricted. And there currently are concerns that there might be what's been termed a regrettable substitution for some of these compounds, as they may offer similar toxic effects to those compounds that they've been used to replace. Then we have further examples, some pretty complex chemistry included. So I've included here the 6,2-F-tab compound. This is an alkyl butane and is the main component of firefighting foams. But it's a compound that's not very often included in testing suites, but is found when investigating firefighting foam impacts. So as I've mentioned, PFOA and PFOS have been widely studied. The toxic effects of these are known, but the other compounds that we'll talk about today and those that are on the screen are not really understood and are an area that we need to do much more research. Okay, so we've got the definition of what PFAS compounds are. They're poly or perfluoroalkyl substances, and depending on the interpretation of that definition, the list of synthetic fluorinated organic chemicals could be 6,000 or substantially more. So we're talking vast numbers of compounds that are sort of held within this PFAS definition. PFAS chemistry was first discovered in the late 1930s, and since the 1950s, many products commonly used by consumers and industry have been manufactured with or from PFAS. The carbon-fluorine bond is extremely strong, which gives PFAS compounds some of their extremely useful properties. So they're known to be water, grease, and dirt repellent. They tend to be thermally and chemically stable, and they can also react as a surfactant. So this has led to widespread use, and I expect there are PFAS containing materials within close proximity to everyone who's on this call today. There are numerous consumer and industrial applications, including aqueous film-forming foams, such as fire suppressants, metal finishing and plating in the electronics industry, hydraulic fluids, fluoropolymer production, paper products and packaging, for example, pizza boxes and coffee cups, semiconductor manufacturing and textiles, most well known being Gore-Tex. And they've also been used to treat carpets and furniture as a stain or dirt repellent. However, the list goes on and on. I've actually included a link here to an excellent paper which provides a great overview of all the various different processes and industries that typically use PFAS compounds in their manufacturing processes. So we've answered what is PFAS, but where will we find it? Well, due to its unique properties, PFAS compounds are widely distributed in the environment. They're persistent, not readily degrading. They are water soluble and highly mobile in the water environment, particularly the shorter chain PFAS. And they're also known to be bioaccumulative in plants, fish, animals, and humans. For this reason, PFAS chemicals are often termed the forever chemical. In England, the EA and DEFRA are also trying to understand where we're going to find PFAS in the environment. They're currently assessing levels occurring in the environment, their sources and potential risks to try and inform future policy and regulatory approaches. Over the next few years, they have set themselves certain milestones they want to achieve, which include the collection of comprehensive surveillance data across England. They want to work with laboratories to develop new analytical methods to improve detection limits. They're wanting to work with industry to assess the risks of PFAS produced in the UK. They're identifying current and legacy uses and mapping potential sources based on their activities. They're completing river catchment investigations and working with water companies not only to investigate and understand PFAS discharges to the sewer system, but also to develop wastewater treatment options. So at this point, I really wanted to share some information that the Environment Agency published back in October 2019. They had a PFAS related study across the whole of the UK. And so I just really wanted to share the data. So really to indicate the distribution of PFAS across England. So as I mentioned, this figure is taken from their PFAS study published in October 2021. But this is an ongoing study, began back in 2016 and is continuing through to the current day. The EA have begun to take samples for PFAS as part of their regular surveillance monitoring. And as you can see, PFAS has been found in surface water samples across the whole of the UK. And typically, where it's been found, it has also been found above the EQS. Due to its persistent nature and widespread use, it's not unexpected to find PFAS everywhere. Migration of PFAS compounds is possible via every conceivable method, either by air, by water, and as we've already spoken about, it's bioaccumulative. So the EA is using its surveillance monitoring to try and understand some of the sources of PFAS in the environment. And with Jacobs, the EA are looking to develop a GIS-based PFAS screening model, which will incorporate sensitivity maps, aquifer types, geology, along with potential PFAS source sites and their surveillance monitoring data. And I understand that the intention is this tool will be available to regulators and authorities in the future to help them to determine the likelihood of PFAS impacts at project sites. So it's at this point, I just wanted to take a bit of a side note and a bit of a break from the rest of the presentation, but I thought this was a really important slide to share. It really highlights an important message, and it was created by Jane Thrasher of Jacobs for this year's Environmental Analyst Groundwater Forum. And what she did was to review the Environment Agency's open data for some of the 2021 groundwater sampling events that they completed, looking at all of the different PFAS compounds. So in this particular slide, Jane has represented a sampling event which targeted 75 groundwater samples, all from different locations, but not linked to specific potential PFAS source sites. And what I think Jane has done really well is to highlight the fact that PFAS impacts are not all PFOA and PFAS. So although PFOA and PFAS compounds are the ones which have been regulated and we know the most about, they're not necessarily the compounds most found or most prevalent in the environment. It's interesting that the EA only extended their sampling suite to 44 PFAS compounds back in 2021. And as you can see, both PFOA and PFAS, although present, return significantly less concentrations than many of the other PFAS compounds, and in particular 6.2 fluorotelmer, which we discussed at the beginning of this presentation. So I think that's an important topic to keep in mind, particularly if we're considering investigating PFAS impacts, that in the past we may have only focused on a couple of the PFAS compounds, but they aren't necessarily the most prevalent in the environment. So getting back to the Environment Agency's study of potential PFAS source sites, we've already seen that they've gathered their surveillance data, but they'd identified that there was only very limited data available on actual investigations into potential PFAS source sites in England, and that more data was needed. We know that PFAS has been widely used in some industries, but it had been recognised that more data on the likely significance of these source types was needed. So to try and help understand the source sites, the EA have developed, or are in the process of developing, a risk ranking of regulated industries. And this is based on the use of PFAS compounds in their processes and in their method of fire prevention and protection. So several industries have received particular attention and have received a higher risk ranking, and those are those listed on the screen. So the oil and gas industry, cement and mineral, paper and textiles, food and drink, metals, chemicals, nuclear. And in addition, the Environment Agency have completed focused site assessments at fire stations, military airfields, wastewater treatment sites, and landfill sites. So if you're working on these types of projects or in close vicinity to some of these sites, then this really should start to be a trigger for whether we should consider PFAS impacts as a potential issue on our project sites. Although in saying that, it has been recognised that the use of fire suppression systems and emergency exercises is the major potential source of PFAS in the environment. So having myself worked in the oil industry, emergency drills where foam was used on a regular occurrence, maybe biannually, to test fire and emergency drills with the fire service was a typical situation. They would typically use the same bund or an area of the site, but it would be clear that wherever that foam was discharged, that will now become a significant source for PFAS impacts. Also, earlier in my career, I also remember attending a tanker rollover incident in Hedge End, and the amount of foam that was spread to suppress the potential for fire was incredible. So again, the locations of past incidents where hazardous materials are spilled can also be a significant source, and they may not be necessarily linked to a typical expected source site. Literature suggests that despite the restrictions on use, older consumer products such as carpets, textiles and upholstery that have been treated with PFAS or PFAS-related substances will continue to act as a source of PFAS. Emissions can occur during the use, washing and disposal of these items entering the environment via either wastewater treatment works or waste management facilities. Additional potential sources of PFAS to the environment include landfills, as we mentioned, industrial discharges, and local historical contamination. And as already mentioned, especially those sites associated with firefighting training, whether that's military bases, airfields, chemical industry sites, or the oil and gas facilities. It's also known that PFAS can be present in soil from historical sources such as the spreading of sewage sludge to land. And we'll see on a later case study that paper pulp also can be a source of PFAS if that is spread on agricultural land as well. So we've now answered where can I find PFAS, which is pretty much everywhere. So this leaves the question, should I be concerned about this? The stability of PFAS and its resistance to degradation results in almost indefinite environmental contamination, leading to the long-term continuous exposure to people and wildlife. So there is worldwide concern at the adverse impact arising from PFAS use on both human health and the environment. There have been toxicological studies focused on PFOA and PFOS that have identified reproductive and child developmental defects. There's also been liver and kidney function defects, and also there's been witnessed tumours in laboratory animals. So agencies around the world are focused on trying to understand the toxic effects and legislate how PFAS is used. The US EPA has a 5-year plan currently to study PFAS, and in June this year published health advisories for 4 PFAS compounds, which dramatically reduce the concentrations at which it might be expected that PFAS would cause negative health effects. And across Europe, we're seeing examples of litigation as a result of PFAS impacts. In Germany, there's the Rastatt case where thousands of tons of PFAS impacted paper waste were spread across agricultural land in the early 2000s. This resulted in impacted drinking water supplies and aquifers. PFAS entered the food chain and left vast areas of agricultural land uneconomical to farm. In Belgium, we've seen protests and litigation regarding the impacts to the community around the 3M manufacturing facility in Antwerp. And in Denmark, the press has reported on impacts to arable farmland and surface waters from runoff from a fire training facility. Those PFAS concentrations were subsequently found in meat produced from those impacted farms and in surface waters, restricting recreational use. In the UK, The Guardian has recently produced a number of articles focused on the quality of drinking water supplies in the UK. And so this is getting a lot of attention through litigation, through regulatory focus. So the answer to the question, should I be concerned? The simple answer is probably yes. PFAS should definitely be considered for many of our projects as a chemical of concern to understand the potential risks and liabilities for our clients. In an ideal world, we would look to our regulations to provide guidance. However, due to the lack of understanding of the toxic effects of these compounds, regulators are playing catch up. I thought I would just share this slide, which compares some of the target concentrations from across Europe. And as you can see, there's quite a huge variation in concentrations, varying by orders of magnitude, and target concentrations for some media, but not others. As I mentioned, studies are ongoing around the world, and in England in particular, DEFRA is looking at grouping PFAS compounds. They're prioritising what they call the PMT compounds, which are those which are persistent, mobile and toxic, to help develop guidance, acceptable concentrations, testing methods. And really this guidance cannot come soon enough. So we are at the end of the presentation, which I hope has raised awareness of the 3 questions posed at the beginning of the presentation, and when there might be a need to consider PFAS as a potential chemical of concern for upcoming site assessments or due diligence projects where there's a potential source, either on site or in close proximity. But before we finish and enter the Q&A session, I just wanted to share what RSK has been doing to follow and respond to the ever-changing PFAS requirements. Last year, Dirk established the PFAS Knowledge Centre, bringing together experts from across the various RSK groups. On the team are representatives from the risk assessment team, toxicologists, remediation specialists, and project managers from the UK, Germany, Belgium, and Australia, who've been managing PFAS projects for some time and have the most experience, capability, and competency within the RSK group. The objective of this group is to assist project teams, sharing best practices and disseminating knowledge. Within the group, they've developed PFAS-specific sampling methodologies, which are available for the whole of RSK. They are tracking regulatory changes globally and sharing their findings. And they're available, approachable, and the standing group to go to support RSK and their clients on PFAS-related projects or queries. So thank you very much for listening today. If you've got any questions, please feel free to submit those questions into the chat. However, if you would like to message either myself or Dirk after this presentation, then our details are on the screen. Thanks very much.
Chris, thank you for the presentation, and we're now going to enter the Q&A stage, and we're joined by Dirk as well. So we've had quite a few questions posted already. Thank you for those. You still have an opportunity to post a question if you have one. We're doing Q&A for about 15 minutes or so. So Dirk, Chris, first question. PFAS, water soluble and water repellent at the same time, question mark. How can it be both?
Yes, yes, PFAS. Then you have to look at the structure of PFAS. PFAS has a head and a tail. It's not a snake, but it has a head and a tail. The head has a functional group, which is hydrophilic. It likes water. It reacts with water. It's soluble in water. And the other part is a tail, which is hydrophobic. It doesn't like water. It likes fat. And it's also soluble in fat. So these two aspects makes that the PFAS can be dirt repellent, fat repellent, or water repellent. Yeah.
Thank you, Dirk. Next question. How was the EQS derived for PFAS, PFOS?
Could you repeat the question?
Yes, Dirk. How was the EQS derived for PFAS and PFOS?
That, yeah, I don't know. I have to go into detail. It's a very low standard, but I don't know how it is derived. Probably it has to do with the fish in the water and the ecosystem, the surface water ecosystem, but I don't know the details about that. So we could reply later on.
Okay, thank you for that. Linked to fish, has testing of marine and freshwater fish been undertaken?
Yeah, so I shared the slide with the surface water concentrations. Over the same period, they were also the Environment Agency were also taking biota samples as well. So over that period, they had, I think it was 57 specific sampling locations that they would sample brown trout, roach, and chub. And what they found is that there is a biota EQS, and for PFAS, 40% of the samples that they tested were above the biota EQS for those fish samples that were tested. So these samples continue to be undertaken. It's a limited testing suite compared to the surveillance monitoring they complete, but it is undertaken on a regular basis.
Okay, thank you. Is there a certified testing method?
Yes. PFAS analysis is done by liquid chromatography and mass spectrometry. It's a specialized analytical technique which is used for chemical compounds. And for PFAS, that's special. They started 20 years ago with the first analysis of PFAS. They had a few PFAS compounds in their protocol, but since then these techniques are improved and optimized, and now they're going to limits more than several orders of magnitude lower, and we can detect more than 40 compounds at the same time in the same run. And probably maybe it will improve in future, but these techniques are in continuous evolution. The laboratories, they are accredited, they are followed up by the government. They do, there's audit testing, so these techniques are becoming more and more elaborated and controlled by the specific organizations. So there's a lot of work to do still, because we have 5,000 compounds. We don't gonna do the testing on 5,000 compounds in one run. That would be too much. We would have a book as an analytical result, but yeah, there will be an improvement of this analytical technique. 2 years ago, we had only 25 compounds. Now we have more than 40 compounds. So it's going very, very quickly.
Yeah, and just to add, certain countries will have some guidance on what they expect in their PFAS suite analysis. The UK hasn't. It will come down to what the laboratories can offer, what the source of PFAS might be on your particular site, on what suite that you select. But you could also miss many PFAS compounds, as we talked about today, if it's not included in that particular suite. And so there are sort of catch-all analysis that's available, which is a top assay analysis, which it could well be for certain projects. You want to do a combination of a suite of analysis plus a catch-all analysis for some projects.
Thank you. Another question. Should we be testing for PFAS during soil sampling? If so, would you recommend that it is regularly tested for, as for example, heavy metals, TPH, and PAH? So I think the question is suggesting, should it become the norm as we do with lots of other contaminants that we test for?
My personal view is that it all comes back to really good desk studies on some of these projects, understanding what the source of the potential contamination is, whether there's been any PFAS use on the site, whether there's been discharges of foam on or off site adjacent to the property, because that will really infer on how the scope of work should develop for your laboratory testing. I'm not advocating that PFAS should be undertaken on every project, but there will be times when I think we're obliged to highlight potential impacts to clients to have that discussion about the scope of work and whether PFAS should be included in a particular project, because it's not a small undertaking. It has sampling complications. The cost associated with testing these samples in the laboratory. So a decision needs to be made, and it's not always a simple one.
Okay, I think linked to that one, I know, for example, Envirolab are looking to purchase high-res LCMS next year. Is the testing houses who can undertake PFAS quite limited at the moment in Europe and UK, or is it quite a common availability?
What's your experience?
Belgium, In UK, I don't know, I'm based in Belgium, but for instance, in Belgium, if we do water analysis on PFAS, that goes to a laboratory in Germany. If we do a soil analysis, we give the task to the lab to do a soil analysis on PFAS. It's going to Holland. There are labs also in Belgium, and all those labs are under surveillance. So there are some testing to control if the results are okay. But it's not only related to Belgium as such. It is really a regional procedure, let's say. Now in Belgium, for instance, since the problems, let's say, with 3M in Antwerp, there's a tremendous request for PFAS analysis, and the labs cannot follow that. We have to go abroad also to complete these analysis, and that's also regulated on a European scale. There is interconnection between different labs and countries, so yeah, but they have to follow the Flemish procedure, the compendium of sampling and analysis, which is elaborated.
And I think in the UK, I mean, it's a similar situation where the choice is limited. Envirolab probably would have a better answer than I can give, but yeah, those accredited labs are few and far between.
Thank you for that. And then again, looking at moving away from testing to remediation, we have a question here. Certain levels of PFAS are found. Are there any techniques to remediate or mitigate risk to health?
Yes, there are some techniques. There are not many techniques. The remediation of PFAS in soil, the first step could be the excavation of the soil, and then afterwards treat the soil. The second technique is to stabilize the spreading of PFAS in the soil, but the latter technique is not common used. It's not used in Belgium. Yeah, there's one company who uses a certain type of liquid activated carbon to build a barrier to which catch let's say the PFAS in the groundwater, so it cannot continue spreading. But this is just in startup, let's say. They had already a lot of experiences in the States, but in Belgium itself, we're mainly focusing on the treatment by washing of the soil. So we have a big capacity in Belgium. We are connected by boat, so we can also go abroad. And what do the washing? The washing, by washing the soil, you concentrate the PFAS mainly in the sludge of the soil, which is then brought to a landfill. And the other part of the soil, the sand fraction, let's say, that is mostly clean, has a good quality, and can be reused. So in that way, we can diminish our volume of contaminated soil by a factor of 5 to 10 even. In other countries, they don't wash the soil. For instance, in the Netherlands, criteria for washing the soil are very severe, more severe than in Belgium. And there are, if the concentration is too high, for instance, above 100 micrograms per kilogram, then all the soil is going to a landfill. Also in other countries, is directly going to a landfill without diminishing the volume of the PFAS fraction. And then at last, you have thermal treatment, but that has a lot of problems. Yeah, you can treat the soil, but if you want to remove and to destroy the PFAS, you need temperatures of more than 1,000 degrees, even to 1,400 degrees. So there's a treatment technique to dissolve the PFAS, to bring it from the solid part of the soil into a volatile state, and then to incinerate the the PFAS at very high temperature. But yeah, you need, as I said, very high temperatures, and there's still some question marks about it. We investigated last year, and there are actually no capabilities to incinerate the PFAS contaminated soil in Belgium and in the Netherlands. There are capabilities, but very limited in Germany. Yeah, another solution could be the cement industry. They can reach temperatures of 1,400 to 2,000 degrees even, and they can completely destroy PFAS. But you know that concentrations must be elevated because the presence of PFAS in soil is rather low. Let's say it's a few 10 to 100 micrograms, 1,000 micrograms. It's still very costly, and I think washing is more economic and than thermal treatment. I don't see directly that thermal treatment will be a BATNIC technique to treat the soil in future.
Yeah, I think the fact that because of its unique properties, the fact that it's chemically and thermally stable, we've got this really strong carbon fluorine bond. It makes it really difficult to destroy. So you end up with a situation where you've always got elements of PFAS at the end of remediation that you've got to do something with, which there's a lot of research at the moment going into different techniques, but up until this point we've been left with activated carbon excavation, soil washing, with some potential thermal treatment, but that's it really.
Okay, just one more question we have. This relates to UK in the manufacturing industry. So this is metal plating activities. And the question is in two parts. Was there an exemption in the UK for the use of PFAS in metal plating? And if so, how long would that exemption be on for? So you broaden that to beyond that activity.
Yeah, so I couldn't give you the answer. We'd have to do some research on that to see whether they've got an exemption or not. I know from my experience in the oil industry that there was an exemption for a short period of time for the use of firefighting foam, which had PFAS containing substances. But that ran out very quickly, and there was protocols on how that material needed to be destroyed and what it could be replaced with. Now, it could well be that some of the products that was used to replace the original PFAS impacts are now being considered as compounds which also need to be replaced with something else. So it's a complicated situation. I'm afraid I can't give you the answer to the metal plating question, but we could probably do some research to find an answer on that.
I think that's looking at the time, Chris. I think we don't have any more questions. So I think on behalf of the 130 odd attendees, I just want to thank you both for the presentation and your responses to the questions today. I just want to thank everybody who's joined the Down to Earth session. The next one will be in September on the 13th, and by Melanie Lyons on managing uncertainty in groundwater risk assessment through good data management. So we're having a month off in August, but join us again in September. There will be a feedback form coming out to you all in the next hour or so. If you could please complete that and return it, and this video will be available on our YouTube channel. So I want to thank everybody and have a good afternoon.
Okay, bye-bye.
Bye.